So, in the last module you have learned about encapsulation. Encapsulation in fact is a very important concept, is a very important object oriented paradigm. So, after learning basic concept of encapsulation, so in today's we have planned a demo where we will learn about different aspects in encapsulation. So, our today's demonstration include how we can create a class, and then for a class how the different objects can be created, and then how we can add many methods in a class, so that a class can take its complete form. An important concept in encapsulation which is very essential for any program is that automatic object initialization. So, this concept is achieved in Java by means of constructor. So, there is a concept of constructor will be demonstrated, and also we will discuss about constructor overloading. So, it is a one part of the polymorphism in Java concept. So, that many constructors can be planned, so that an object can be initialized in a different ways, and there are some concept that is very much used to resolve certain collision. It is called the namespace collision resolution. So, this is achieved by means of a special Java keyword called the this. So, we shall learn about this in this lecture. So, let us have the demo. So, first we will discuss about how we can create a class, right. We will discuss a program, very small program. Let us have a very small program. In our theoretical discussion, we have discussed about one class called the circle. So, here we can see this is the, where is the highlighter. Yeah. So, here we see we declare the class circle here. So, this class circle has 3 data, namely x, y and r. All 3 data are declared as double. In addition to these data, also this class has 2 methods, one is circumference and another is area. So, the 2 methods are defined here. So, this completes the definition of a class called circle. Now, once this class is declared, you can keep this class in a separate file or in the same file where the main class will include. Now, here in the following we discuss the main class, which is saved in the same file. The name of the main class in this case is demonstration 3.1. Now, in this class we see how we can create an object of the class type C circle. So, we create an object, the name of the object is C, and to create an object you can note it the new operator which is used here. So, new and then again circle, and then within the parenthesis it is basically the general syntax to declare an object. So, with this statement we declare an object called the C. The object is created. However, the different data that is there for this object is yet to be initialized. So, in the following 3 statements we initialize the members x, y and r with the values 0.0, 0.0 and 5.0. So, this completes the creation of an object. In this case the name of the object is C. Now, once this object is created, we can access any values in this object. So, in the next statement we just printing the circumference of the circle that we have created. Now, in order to access the method circumference, you note that we use C dot circumference. So, this means that we call the method circumference of the object C. In the next statement again we call the method area of the object C. This means in this statement we shall be able to print the area of the circle which we have just now created. Now, let us have the demo. We will compile, we will save this program as here the name of the main class is demonstration underscore 31, we should save this file as the demonstration underscore 31.java, and then we can compile using JavaScript. So, let us see the compilation JavaC demonstration. Okay. So, we just compile it, as there is no error. So, compilation is successful. We can run this program using the Java command. Java is an interpreter. So, run this program, and you see running this program, and then circumference here in this circle, that is calculated as 31.4159, and the area is calculated 75. Now, we have learned about how encapsulation is possible. Here in the form of encapsulation, we create a class circle, and for this class we created an object. Now, here question is arised that whether we can create only one object in one program or many objects in a program. The answer is that multiple objects can be created for one class, even multiple objects can be created for other classes also, many classes also. Now, in our next demonstration, we will see how for the same class, say circle, the multiple circles can be created, and let us have the demo here. Again we use the same declaration of the circle class here, it is as usual in the earlier one. Now, only we change the main program, main class. So, we name this main class as demonstration underscore 32. Now, here you can see we have created two objects C1 and C2. In the earlier example, we have created only one object, here we have created two objects, and for these two objects C1 and C2, we initialize its data values, namely for the first object x, y and r are initialized as 3.0, 4.0, 5.0, whereas for the second object C2, we initialize the same set of values with minus 4.0, minus 8.0, 10.0. Thus, two objects are created and their data are also initialized. Now, in the next 4 statements, we see how we can access the different methods in these two objects, namely circumference and area. So, it is the same as earlier program, except that for two different objects we have used it. Now, let us have the demo for this. So, in this case two objects are created and you will be able to get the values of the two objects here. So, same process, we can compile it and then we can run it. Yeah. So, now we can see the two different objects, and as the objects are different, their area and then circumference as printed here is also different. So, now we have understood that how for a class many objects can be created. In this case we have considered two, there may be a large number of objects of the same class can be created. Now, in our next demonstration is that whether one program can include more than one classes or not. So, this demonstration includes the same. Now, here we include one class, namely the circle, which has the same definition as earlier. In addition to this class, we declare one more class. The name of this class which it has been given is called the box. This class box has 3 data field: width, height and depth. In addition to these 3 field, it has also two methods, namely area and volume. You note that the method area, which is defined in class box, is totally different the method which is defined for the class circle. So, the two methods are defined in two classes, but they are different, they are not same, which we have defined in a different way. On the other hand, circumference is a unique method in the class circle, whereas the volume is also a unique method in the class box. So, this way we create two classes, namely circle and box. We can save all these two classes in the same file as the main class. Now, let us have the look of the main class. We give the name of the main class as demonstration underscore 33. This is the main class which includes the main method, and now we see that in this main method we create two objects, one object of the type class circle, another object of the type class box. So, the two objects c, small c and small b are created here. Now, again as it was in the case of circle, we initialize the value, here also the objects that we have created to initialize their values. So, here in the first statement we initialize the value of the circle objects with 3.0, 4.0 and 5.0, whereas for the box object we initialize the value of width, height and depth as the values 3.0, 4.0, 5.0. So, this completes creation of two different type of objects of two different classes. Now, in the next 4 statements we can access the different methods, as we have seen here. For the circle C we access the area and circumference, and for the box B we access the area and volume. Now, let us have the execution of this program. We will be able to see that the two objects they are defined in terms of their classes, and then they can access by the main method. Yeah. So, now we can see that for the first two printout is basically the display basically circle, a circumference and area, and next two output is for the box area of the box and volume of the box. Now, we have understood about that how many classes can be created. It is not necessary that all the classes should be maintained in the same file in the main class. We will discuss about organization of the classes in our program, that will be discussed in due time, not now. So, now let us see, here we can see when we create an object. So, it is our responsibility to initialize the objects. Initialization of an object means initialization of all the member elements that belongs to the object. For example, for the circle x, y, r, for the box width, height and depth, we have to do the initialization, but this initialization as we have done in the last few examples little bit tedious, because we have to do forcefully anyway, but the initialization can be done more sophisticated way. In our next program we will see how the initialization of the objects can be done in an easy way. So, here is one example 3.4, right, let us see. Yeah. So, now we have declared here another class point. It has two member elements x and y declared as integer. It does not have any method in this case. Anyway, we want to discuss about how this x, y value can be initialized. Now, here if you see, this is the usual procedure that we can create an object of type class, and for this thing we can initialize the value from the main program. This is the usual procedure that we have learned earlier. Apart from this process, now we will discuss about we can initialize by calling some methods. Now, so to do these things we have to declare a method in the class point itself. Now, let us see the next class 3.5 as the demo. We can see the class point is little bit redefined with another method. The name of the method which we have included here, set point. This set point has been planned to initialize its value. So, here example we can see the set point method has the two initialization statement x equals to 10 and y equals to 10. Now, come to the creation of an object. Now, we create this object via a main class. Here the name of the main class is demonstration underscore 35, and we have declared one variable distance. Okay, it will be not useful here in this context anyway, but here see we create an object p of class point, the next statement here, and then we call the set point method. It basically initialize the values for the object p, and as you know, by means of initialization method set point, it will initialize as x equals to 10 and y equals to 10. Now, in the next two statement, if we can print the value of the x and y of the object p, it will be printed like this. Now, let us run this program. See, let us go. Yeah, we are now executing this program, the program that demonstration underscore 35, which basically includes the point class declaration and then set point the method there, and then we will create an object of that type. okay, dot Java. Yeah. So, the object the program is now successfully compiled. We just going to run it 315. Okay, fine. So, let us see here. So, here we can see the object is created and we did not do any initialization in the main method. We did the initialization via the set point method and the initialization here x equals to 10 and y equals to 10. Now, here we can see that initialization this method, but however, this method always initialize only with certain initialization. Here for example, x equals to 10, y equals to 10. This means that if we create any other objects, it will, and we call the set point method for initial, we should always initialize with the same 10 10. So, this is not a good and not desirable. Now, we will have a good method that how the initialization object can be done with the different data values. So, in that case we have to again rewrite this function this method using passing argument. Now, here is an example, we just slightly change this class declaration and set point method also passing two values a and b. Here a and b are the two values to be passed to this method. So, that a can be used to initialize the value of x and b can be used to initialize the value of y, and the rest of the program is same as earlier one, but only the difference you can see when we call this set point we pass 15 20. That means, in this case the object p which we have created, it can be initialized with its x value as 15 and y value as 20. Now, let us run this program and then have a quick demo. Yeah. So, 3.6 right. Now, let us run this and we will see the object data member will be printed as 15 20. Now, let us come to the program. We can call this method or we can create another object, say p 1 and p 2. We are creating two objects p 1 and p 2 here, right, the p 1 and p 2. Okay. Again set point we just okay, one keep it 1, another p 2, another say 0 and 0, p 1 p 2 0 p 1 and p 2 and 0 0. Okay. So, we create two objects, one is 15 20 as the value of x and y, another is 0 0. Now, again we can print it, just two statements. So, we can print the values of two objects here, right. For first one is p 1 dot x, p 1 dot y, p 2 dot x, p 2 dot y, right. Now, let us save this program. Now, here we have created two objects and the two objects are initialized with their own values, and then we use this main method to print their values by which it is. Now, we can see that the two objects are created and they have been initialized by their own values by means of set point method. Now, here is the one idea about we have to explicitly initialize the object by means of declaring and defining the method. In Java, a unique features are available which basically help Java programmer to automatically initialize the objects, and that initialization through at the time when the object is created itself. Now, this concept, the automatic initialization at the time of creating an object, is called constructor. In our next example, we will see how the automatic object initialization using the concept of constructor is possible. Now, let us have the program here, not this program, go to the program number 3.8. So, let us have a simple program which basically help us to automatically create the objects and then initialize it. Now, let us have the program here. Now, the class again we can continue our this demonstration with the class circle. This class circle has the three member elements x, y, r, two methods circumference and area. Now, we declare one method. This is a new method that we have added here in this class. The name of this method you see is the same as the name of the class. This is a unique thing here, the name of the method is same as the name of the class. And also you can note, in this case this method does not have any return type. So, this is called a constructor which basically has the same name as the name of the class itself, and it should not have any return type. Now, here the name of the constructor is therefore circle, and this constructor is defined with 3 arguments. All these 3 arguments are of type double A, B and C. Here basically A is the argument which will be passed to the value x, B is another argument whose value will be passed to y, and C is another argument whose value will be passed to r. This means that if we can create an object passing 3 values, and these 3 values will be used to initialize its member element. Now, let us have the main class here. After defining this circle, we can initialize the objects. Now, here we see at the time of creating the object. So, we are creating the objects using the new operator here. Now, in the first creation we create the object C1 and we pass 3 values 3.0, 4.0, 5.0. This means that constructor, it will call the method circle, which is the constructor method, and pass this value to the circle object C1. Similarly, C2 object will be initialized. After the initialization is over, the method will be accessed and then method will print the different values according to the calculation or definition of the method. Now, let us have the execution. Execution is the same as earlier. There is no difference so far the compilation execution is concerned. However, from the result point of view, it is more sophisticated way of initialization. Yeah. So, we have created the object at the time we have initialized the object at the time of creating the objects, and then this is by means of constructor. This concept is called constructor, as I told you. Now, constructor has its more dimension, in the sense that it also gives a lot of flexibility to a programmer to initialize an object in a different way. Now, if you want to initialize the object in a different way, then you have to define so many constructors for your own requirement. Now, this concept is called the constructor overloading. Now, here again let us come to the discussion of the class circle. In the last example, we have discussed about how the automatic initialization by means of a constructor with 3 arguments, we have defined it. Now, in addition to this, we want to define another way of initializing. Here is the next constructor that we have declared. Here if you see, this constructor has only one argument double C, and the constructor is defined like this. If we call a constructor with one argument, then it will initialize their member elements with x equals to 0, y equals to 0 and r equals to 0 as per this definition. That means, if we create an object passing only one argument, then the Java runtime compiler will automatically understand that this constructor should be invoked. If we create an object passing 3 arguments, then the first constructor will be called. Now, here again you see the third constructor that we have defined here, it is a little bit different. Here we can pass an argument which is the object itself, that is quite possible. So, here the circle C another object which has been passed. If we passed it, this means that the new object that will be created having the same data member as the circle C here. So, this is the one constructor, that means a duplicate on object can be created. Duplicate object in the sense that they are different objects, however, same data values. Another way is called the default constructor. If you define a constructor without passing an argument, then it is called the default constructor. So, in this case the last constructor, the fourth constructor in the series is called the default constructor. Here the default constructor means that x equals to 0.0, y equals to 0.0, r equals to 1.0. Now, let us have the main program. So, main program is defined here by means of main class demonstration underscore 39. Now, here we see we have created 4 objects and each objects are created with their own constructor. So, the first object C1 created with the first constructor, second object with the second constructor and third object with the third constructor, and finally this one here. Okay, so here if you see the C3 and C1, when we create the object C3, we pass the C1 which is an object of the class circle as per the third constructor declaration, and the rest of the things are basically printing the different parameters, area and circumference for the 4 circles that we have created, and definitely C1 and C3 should give the same result. Now, let us have the demonstration. Yeah. So, let us have the quick demo. Here we are overloading constructor. Yeah. Now, so all 4 objects are created automatically, and the objects are created at the time of creation of creating object, I mean declaration, and by passing the values. So, this is about the overloading constructors. Now, there are few more important and interesting facts about this class and then object constructor. We will just want to discuss quickly one concept, it is called the this keyword. Now, this keyword concept can be understood very easily if we follow this example. Now, let us consider the declaration of one class called the student. Here this class has 4 member elements, here integer, roll number, name and course as the string type, and then p as the float. Now, here again we see this is the constructor declaration, roll number, name, string, course, and this. Now, here you can note the arguments that we have passed, they have their name, and in this case the name of the data members are also same. Now, if we try to initialize, then definitely, so for roll number equals to roll number, then this is not the correct. Similarly, name equals to name, it is also little bit ambiguous. So, what we can do is that we can define it by means of this one. So, this dot roll number indicates that this roll number belongs to this class member, whereas only roll number is the argument that has been passed. Similarly, this dot name specify these are name members of the class student, and this dot course the name member of the class course. Now, so now if we run this one, we will see exactly how we, okay, the next part we will discuss later on. Let us see how we can use it. So, this is basically this keyword which basically help us to resolve the namespace collision. So, in this case roll number, name and course is been collided with the data member, it is there. So, in order to resolve it, we can use the this keyword. So, here we have used it and then we passed it. So, now you can see the first time when the object is created, first object Ankit Java 0.0, and now let us come to another way. Now, this point we will discuss. Okay, let us come to the special use of this keyword, and another 3.11. Let us run the 3.11 demo. Now, okay, we will just discuss one more important thing here. Now, in the context of circle, again the this keyword can be understood very precisely. So, here again constructor, we can see the constructor has been defined with x, y, r, which have the same name as the member element, and we resolve it by using this. These are the same thing applicable to the other also. So, if we want to resolve some name which belongs to the same class with other variable, so we should use this. So, this is the one use of this keyword in Java program. Now, there is another use of this program in the Java keyword. To understand these things, let us have a simple program. Let us have the program 3.12. Yeah. Now, here we can see that this can be used to have some other advantage. See here, let us have the program, very simple one, it is very easy to understand. A is the class which is declared here, and it has one method m, another method n. The method m will simply print hello m, n also will print simple one string hello n. Now, if we want to access the same method in some other method, then definitely we have already learned that in order to access a method, we should create an object, but whenever we are declaring a method or defining a method, there is no question of creating any objects. Now, if the objects belongs to the same, that means if you want to access the method which is in the same class, then we can resolve it by specifying this dot m. For example, in the method void n, we call the method m which is defined in this class itself. So, in order to resolve it, we use the this dot m. This means that void n, whenever we call for a new object created here, for example a, then this will call the method m as well as method n. So, this when a dot n, that means we call the method n, it will print hello n and then it will print that hello m. Now, let us have the quick execution of this program, so that we can understand about this one. So, this method is used to refer one method which belongs to the same class without creating an object. Now, this is the demonstration execution run of the program that we have discussed now. Okay, we can understand. So, that the method m has been called from via n method which is defined there. Now, let us have another quick example of this method. It has many purpose that can be used. We want to give another So, this is the one method you see. So, class A is declared and A is the constructor. Go to the constructor definition there. A constructor is there. Okay, fine. We are clearing the A constructor. Now, here the constructor, there are two constructors, right. The first constructor, okay, let us come to the second constructor. What is the second constructor? We define the second constructor by means of passing an argument that type integer. So, this means it will like this one, right. Now, here one default constructor which is defined, which basically initialized by a default value say 5, but that initialization calling by the one already defined constructor, namely a int x. So, if you want to call any constructor within another constructor, then you can use this and then specifying the parameter values that you want to have. Now, let us have the execution of this program. So, this basically call a constructor in a constructor, and this constructor is basically a nesting type of call. It is also part of the overloading constructor. Yes, so execution is there. So, we can see how the whenever we create an object here in the statement a equals to new a, we call the default constructor when first constructor. Whenever the first constructor is called, it basically initialize the member elements with value 5. Here no member, actually the value is 5 is passed to the class object, and then it print hello a using this value x. So, basically it print as 5. So, this is the way. Now, let us have a last demo. It is more interesting to understand. So, the last demo, it will be easier to understand. Now, again circle class, we create the one constructor is basically using 3 parameters. Now, this constructor then can be used to define other constructor by means of this the methods. So, circle, for example, second one, this we call the same constructor here by using the this and passing 0.0 0.0 r. Similarly, the second constructor we use this c dot x, c dot y, c dot r. Here this and all this basically indicates the one privileged constructor which has the 3 parameters and automatically it call them. So, this way it basically has a little bit change in the similar program that we have discussed earlier, that this use of this operator. So, we have discussed about constructor overloading, and just last things I just want to mention about. So far the constructor overloading is concerned, two constructors can be treated as different if they are different in terms of the argument, number of arguments and the type of arguments. So, that is the only things are there that you can already realize about it, and if you can go through the all examples, then you will be able to understand that all 3 constructors or whatever the constructor, they are different because of the different argument that we have passed. Okay. So, this concludes our demonstration on encapsulation. Thank you very much.